Hello guys. So let's begin with the problem arithmetic slices to subsequences. So let's first try to understand the problem statement. So integer array nums is given and we need to find all the arithmetic subsequences in the nums integer, in the nums array. So we are only allowed to count those subsequences. Those are within at least length of 3. So we can count all those with the length of 3 or more than 3. So first of all, what is arithmetic? So here arithmetic is denoting as a AP. So for let's see this example. So 1, 3, 5, 7, 9. So here the difference between any consecutive pair is same. So this is following a AP. The sequence is. So this is called arithmetic, and subsequence is basically, if you see here, so 2, 5, 10 is a one subsequence of this array. I hope the problem statement is clear to you. So if you know the longest increasing subsequence problem, then it's good for you. The n square solution, the db solution, n square solution of it. If you don't know, then it's also okay. So I am going to explain my approach by taking the example one and trying to dry run on it. So first of all, here I am going to make a two state. The first one is denoting the each index, and the second one is for difference. And I will count all the difference for that index. So let me do a dry run for the first example. So as you can see here, nums equals to 2, 4, 6, 8, 10 is given. So in this do loop, so whatever we did in the LIS problem, I'm going to do the same thing. So first of all, for the each index in the from starting from again in the other loop, I will start from 0, 0 to I minus 1. I will find out the number of pair count that exist with that difference, and I will add to that index each time. Let's see. So when I will start from 1 and j equals to 0. So j is 0 and I equals to 1. So 4 minus 2, the difference is 2, and index j, there is no any pair with a difference of 2. So just this is the first count. So just add the pair 2 comma 1 into the index 1. Now move the index to the next index. So now I becomes 2 and j starts j from index 0. So 6 minus 2, the difference is 4. So just check, is there any pair with a difference of 4 in index 0? There is no any pair. So this is the first count with the difference 4. So just add 4 comma 1 into the index 2. When j equals to 1, the difference is 2. So 6. So first of all, check, is there any pair exist with a difference of 2 in the index 1? Means j is denoting to 1. So yes, there is a one pair with a difference of 2. So now count is 1. So 1 plus 1, it becomes 2. So now what it's denoting here? It's denoting that there is already one sequence is exist with a difference of 2. And by using this 6, I can make a two sequence with a difference of 2. But if you see, what is this, which sequence can I able to add here? So this is 2, 4, 6, because we need at least 2. We need at least 2. So that's why 1. So this is here you can see 2, 4, 6 is the first sequence that I will add to my answer. Okay, just move on the I. So now my I becomes I equals to 3 and start j equals to 0. So now the difference is 8 minus 2, that is 6. There is no any pair exist with the difference of 6. So just add 6 comma 1. Similarly, there is no any pair difference 4 minus 8 minus 4. So difference is 4. So just add 4 comma 1. 8 minus 6 when j equals to 2. So the difference is 2 and index j equals to 2. There is a pair 2 with a difference 2 is exist here. And it's saying that the counts are 2. So 2, and if I take one more, so 2 plus 1, 3. So now my count is 3. So it's showing that if by using these two sequences and also taking 10, we can make two new subsequence that is greater than the length of 3, and that those sequences will be the part of our answer. So those sequences, which are those sequences? So those are, you can see here, like by using 8. So those are 8, 6, 4. This is the one, 4, 6, 8, and the other one is the 2, 4, 6, 8. 2, 4, 6, 8. So this is the two sequence that will add into our answer. Okay. Again, increment the I. Now I is at the last index, and again starts j from 0. So again 10 minus 2, the difference is 8. There is no any pair in the index 0, j equals to 0. So just add 8 comma 1. Again for the j equals to 1, the difference is 6. And again there is no any difference with a difference of 6 pair. So add 6 comma 1. Similarly, 10 minus 6, the difference is 4. So there is no any pair with a okay, so there is one pair, 4 comma 1 in the index 2. So 1 plus 1, 2. So it's showing that there is one sequence is there, and by using this 10, I can make, I can make, I can make a new sequence that will add to our answer. So which is the sequence is, so here, so basically 4 1 with the index 2. So basically 6, so 2, 6 and 10. If you can see here, the difference is 4. 2 plus 4 6, and 6 plus 4 10. So 2 6 10 is the, so that's why we are adding this sequence into our answer. Again, when 8 comma 10, so difference is 2, and for j equals to 3, so there is already exist three sequences. So now my new pair will become 2 comma 4, 3 plus 1 count 4, and it's showing that three sequences are exist already. So I can make, by using this 10, I can create other new three sequences that will add to my answer. And these are those. So basically these are 6 8 10, 4 6 8 10, and 2 4 6 8 10. So if you see, these are the all 7 possible AP sequences for the example 1. 1 plus 2 plus 3, 4, 5, 6, 7. Okay, I hope my approach is clear to you. If you don't understand, if you have some problem, then just continue with me. I'm going to implement it, and so that you can get a more clear idea. Okay, so first of all, you need a data structure. Which type of data structure? So here for the DP state, the first state will store the indexes, represent the indexes, and the second state is represent the difference. So the difference is maybe in the range of, as you can see here, 2 to the power 31, and if I add minus 2 to the power 31 to this number, it may be in the range of long. So I cannot directly write it in a vector, the second state. So for that, I'm going to use here an ordered map. For first index vector, and for the second index, I'm going to use an ordered map. So for that, just inside the vector, just take an ordered map. Okay, ordered map. So the difference may be in the range of long. So just long comma int. Int is basically store your count. So tpn. Okay, for storing answer, just take an answer variable and initialize it 0. Okay, so for the first loop, I will start from 1 and I will go up to n, to the last element of the num integer. Okay, the inner loop will start from j equals to 0, and it run each time j lesser than I, means I minus 1, j plus plus. Okay, so first of all, what is the difference? So the difference is nums of I minus nums of j. But maybe this difference is in the range of long. So just convert it into long. Okay. Okay. So now I will check, is there any pair exist in the index j with a j comma difference. So int count equals to dp of j dot dp of j dot count diff. If not equals to 0, then just take dp of j comma diff, and if it is not exist, then take 0 into your count variable and add it dp of I comma diff plus equals to 1 plus count, and just add this count into your answer. Okay, here means I can also directly access dp of j comma diff, j diff, but actually we are using here unordered map. So if that pair is not there, and if I will directly access it, then that pair will be created, and it will wastage of memory and time. It will increase your time complexity also. So it's better to first check whether that j comma diff state is there, present there or not, and at last return answer. Okay, let me run it. Okay, unordered. Just a minute, just a minute. Vector ORD, unordered. Even ORD E, unordered. What is the spelling? UNORDERED. Okay, so here n is not there, n is not declared, not defined there. So that's why it's give me a compile time error. I have declared it. Let me run it. So it's running fine. Let me submit it. Okay, 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 okay. So again, there is one. Okay, so I made a one mistake. Difference is in the range of long longs. I need to declare it as a long long. Okay, so it's running fine. Let me submit it. Okay, so the solution get accepted. Okay, so that's all for this problem.